Okay. Yeah, I'm going to start at the beginning and we'll get through as kind of as much as we can. Sound good to you guys? All right. Okay, so for 51, the first thing you guys should have done is to factor off a cosine. Yeah. And then we can apply that zero product property and set each of these two pieces equal to 0. To solve cosine x equal to 0, we can do the cosine inverse of both sides. And 0 is a unit circle value. When I go look at my unit circle, I see that the x-coordinate is 0 at pi over 4. Or I'm sorry, at pi over 2 and 3 pi over 2. To solve this piece, I'm going to add the 1 over and then divide by the 2. And when I take the sine inverse of both sides, I notice that sine of 1/2 is a unit circle value. So I'm going to go look for where the y-coordinate is positive 1/2. That happens at pi over 6 and 5 pi over 6. And the directions here say find all the solutions between 0 and 2 pi, so I am done at that point. Sure. Yeah. Yeah. How about for this one? First step should be to get it equal to 0. So we'll subtract that tangent over. Good. Hi. This person's in B11. Because they don't realize that the kids stayed in the same room and the teachers moved to different. I don't know. Yeah, you would have thought, but who knows? We only got a couple more weeks of it. First thing I do after that, or now, would be to hopefully factor off a tangent is what you'd say. I can then use the zero product property to rewrite these as two separate pieces. And remember that tangent is sine over cosine. Tangent of 0 is a unit circle value. I'm basically going and looking for where the y-coordinate, the sine value, is 0. That happens at 0, and then again at pi, and then again at 2 pi. But I'm not going to write 2 pi down because the instructions say I'm looking for my solutions not including 2 pi, right? So I have those. And here I'll add 1 to both sides and square root both sides. Yep. And then this, because of the plus or minus, okay, come on, I have to split into 2 pieces. And when I do the sine inverse of 1, that's a unit circle value. That happens at pi over 2, and only pi over 2. And when I do sine inverse of negative 1, that happens at only 3 pi over 2. And then I have to be a little bit careful here. Why do I have to be careful on this one? Because of the tangent. What do I also have to worry about? I have to worry about where tangent is undefined at. Remember that tangent is y over x, sine over cosine. So I need to worry about where the x coordinates are 0. That happens at pi over 2 and 3 pi over 2. Notice that those are other answers that I have. So I can discard those answers because it won't actually equal 0 there because I have an undefined. So my only answers then are 0 and pi. So let's just go and illustrate what's going on here. So I'm going to pull up my calculator. And if I do, if I try to do tangent of pi over 2, sine squared pi over 2 minus tangent pi over 2, make sure I'm in radian mode real quick. So I do tangent pi over 2 times sine pi over 2 squared minus tangent pi over 2. Now, if this is a solution, this should give me 0, right? Let's see what happens when I press enter. I get an error. Why am I getting an error? Because tangent is undefined at pi over 2, which means that pi over 2 is not actually going to give me 0 like it's supposed to. And the reason it's not is because that tangent part is getting in the way of it, equaling 0 there. So whenever I have one of these tangents, when I solve for a tangent or a cotangent, I have to go back and look at where is that undefined at. Specifically, the only places where tangent is undefined is pi over 2 and 3 pi over 2. And if those are answers I'm getting from some other part, I need to discard them because the tangent being undefined there overrules that part being 0 there. Does that make a little bit more sense? Okay. Yeah, so what I was just doing here is I was demonstrating that if I take this equation and I plugged this answer back in, I did not get 0 like I was supposed to. I got undefined. And the reason I'm getting undefined is because tangent is undefined at pi over 2, and that overrules like the sine squared minus x being, sine squared x minus 1 being 0 there, because 0 times undefined is still undefined. If that makes any kind of sense. So that's rare, but it can happen, and I figure, let's be careful about it. Okay, so here I have tangent squared x equals 3. Now, do I need this thing to equal 0 here? To start with? I would say no. And the reason is because there's only just one kind of trig function here, right? I just have tangent squares. There's no other trig functions anywhere here. So I can just solve this for tangent directly by square rooting both sides, right? And then if I do tan inverse of both sides, then I have to split this into 2. And then we'll do tan inverse of both sides. And this is a unit circle value. Remember that tangent is sine over cosine. So I see at pi over 3 and also at 4 pi over 3. I get positive cosine, or positive square root 3. And for negative cosine, I get that at 2 pi over 3. And then again at, where is it? 5 pi over 3. And that's it for that one. Is everybody so far so good? Okay. Here they get a little bit trickier because you have to do some factoring for some of these now. So for this one, I'm going to pretend that y is the same thing as cosine x. So I have 4y squared minus y plus 1. That looks awfully quadratic to me. We know how to factor one of these things. We want to find two numbers that multiply to give me the a coefficient times the c coefficient, and add to give me the b coefficient. Hopefully you'll notice that those two numbers are -2 and -2. So what do I use those two numbers for? I use them to break up that middle term. And then I make my two groups. The first group I can take out a 2y. The second group I can take out a -1. And you'll notice that in each of these terms we have this 2 minus y part in common. So that can act like a greatest common factor, and I can take the 2y minus 1 part off, and I have a 2y minus 1 part left. And then I can break this into two parts using the zero product property. Now it's silly to do that because they're identical, right? So I really only need to do it for one of them. I mean, technically the other one's still there, but who cares? We don't need to do it twice. Let's half our work. So I get that y is 1/2. But we don't want to solve for y. We want to solve for x, right? What was y? What did we say y was equal to? Cosine x. And then we do cosine inverse to both sides. And that is a unit circle value. So I go and I look for when the x is 1/2. That happens at pi over 3. And then again at 5 pi over 3. And it says all solutions. So how do I change that? Yeah. Good. Exactly right. So that's all we need to do, right, is we just tack that part on at the end. I'll give everybody a minute to kind of catch up on that one. Yeah, Luke, you betcha. Because this one asks us to find all solutions in the directions, and the other one's asked us to find all solutions between 0 and 2 pi. So it's just a directions thing. There's nothing about the problem. It just came from the directions. 59. And again, it says theta's in the problem, but I'm just going to replace them with x's. I hope nobody's confused by that. All right. First thing I would do here is, what do you think? Well, you could, but I noticed that I just have two terms. Yeah, so I can factor sine x off. It's not wrong to turn them into y's. You'd probably still do the same thing then and factor a y off. If you wrote it that way, there's not wrong to do that. But since it's not a quadratic and there's nothing kind of sneaky going on, I'm not going to write it that way. Again, but not wrong if you did, right? You'll still can get to the same spot. And then we can just break this up into two pieces. So here we have sine inverse of 0. And that's a unit circle value. That happens at 0, and then again at pi. And remember, they asked for all solutions, so I have this plus 2 pi k, k an integer. But hold on a second. Look at what's going on here. Is there a way I could combine this? So notice this first line is like 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, etc. The bottom set of answers is going to be 1 pi, 3 pi, 5 pi, 7 pi, 9 pi, etc. So if I put them together, I would get like 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, etc. Everybody agree with that? So I could take both of those together and write it like this. Again, that's like the bonus answer, if you notice to do that. If you don't, it's okay. The other answer is still full credit. It just, if you notice that you can do that combining, I'd give you bonus for that. Everybody's good? Okay. The next one, we're going to add the 2 over. And we do sine inverse of both sides. And hopefully you notice that 2 is not a unit circle value for sine. And maybe you tried to type this in your calculator. What happened when you tried to type in your calculator? You got an error. Why would we get an error here? Yeah, the domain for sine inverse is only from -1 to +1. So this just part has no solution to it. So you only have this answer over here, depending on which one you gave. So again, you can't do sine inverse or cosine inverse of things larger than 1 or smaller than -1. If you do and type in your calculator, you're going to get an error. Doesn't mean you did anything wrong. It just means that that part doesn't have a solution to it. In fact, the error is going to say domain error or something, I think. Right? These are plugging something in that's outside of its domain. And then our last one. Oh, this is tricky. So this one says cosine of sine of x equals 1. First thing I got to do is I got to get rid of that cosine on the outside. How do we do that? I'm going to do a cosine inverse to both sides. Is that, no, yeah, 3. So that cancels those. And I'm left with sine x. And then cosine inverse of 1. Hopefully you notice that that's a unit circle value. That happens just when cosine is equal to 0. Or 2 pi or 4 pi or 6 pi. I'm just going to write 0 there, though, because that's enough. Now I got to get rid of that sine. How do I do that? Sine inverse, right? Yeah. So those cancel out. And sine inverse of 0, that's a unit circle value. If I go and I look at where the y-coordinate of sine is 0, that happens at 0. And then it happens again at pi. So since this is asking me for all solutions then, I just tack on my infinitely many solutions piece to it. And that's all she wrote. Does anybody notice anything? Yeah, that's fine. You could do that same combining trick here, right? Again, this piece is like 0, 2 pi, 4 pi, etc. This one is like pi, 3 pi, 5 pi, etc. If I put them together, I could just write it as 0 plus pi k. So instead of going up by 2 pi's, we just go up by 1 pi's. But this is the bonus one. Again, if you don't notice to do that, that's okay. Whew. We ripped through those ones here, kiddos. What do you guys think? You think so? Okay. Let's see. Are there any other good ones in here that we need to practice? Okay. So, who's ready to do some more practice on this particular topic? Sure? How would this homework go last night? Meh? Okay. Fair enough. Let's do 52 to 62 evens then on that same page 411. This will be the last homework assignment though on this topic. We'll probably give you guys a review for Monday. We'll probably go through it on Tuesday, and then we'll plan on taking a test one of those first 2 days we come back from Thanksgiving. I don't want to try to cram it in before Thanksgiving because I'm guessing everybody else is trying to do that, and you probably have 4 or 5 tests in those 2 days. So we'll wait. Not a big deal. We'll try to do it one of those 2 days. Okay? Monday or Tuesday, probably when we're coming back after Thanksgiving. It's okay. You can make it up when you get back. So like, we'll probably give you guys the review and talk about it on the 20th and 21st.